Hey everyone, and welcome to today's Explainer. We hear a lot about the water cycle or the oxygen cycle, and those are absolutely crucial systems keeping our world turning. But today we're going to audit the most massive, intricate, and honestly fascinating bank account in existence, the Earth's carbon cycle. Think of our planet as this colossal bank, where carbon is the ultimate currency, constantly moving between different accounts. Understanding this planetary ledger is really the key to figuring out exactly how our Earth breathes, grows, and sustains itself.
Just look at that number, 1 billion. Now, when we're auditing the Earth's carbon accounts, dealing in pounds or even regular tons just isn't going to cut it. The amounts are simply too massive. So, scientists use a unit of measurement that equals 1 billion metric tons. We call this a gigaton. To wrap your head around just 1 gigaton, imagine the weight of all human-made structures on Earth, or roughly 10,000 fully loaded aircraft carriers just stacked together. It's a literally astronomical amount of mass. And as we go through this today, I want you to keep this crazy scale in mind because we're going to be tracking tens of thousands of these billions of tons as they continuously flow all around the globe.
So our official currency for this audit is G-tons, or gigatons of carbon. As we dig into the numbers, we're going to focus on two fundamental concepts. First up is storage. Think of storage exactly like your long-term savings account. It tells us how much carbon is sitting securely locked away in a specific vault at any given time. Second, we have fluxes. Now, fluxes are basically your daily checking account transactions, the continuous deposits and withdrawals of carbon moving rapidly from one account to another every single year. Both metrics are super important, but they tell us entirely different things about the health of our planet.
Okay, let's dive into this. At first glance, I know, this complex web looks like a giant puzzle. There are numbers everywhere and arrows pointing in a million directions. But don't worry, we're going to break this down step by step. The trick to reading this map is simple. The black numbers you see are our storage, that current static balance in our savings accounts. The purple numbers, those represent our flux, the active annual transaction rate of carbon moving around our checking accounts. Once you start looking at the matrix this way, the whole planet starts to make perfect sense.
Section 1. Carbon reservoirs on land. Let's start our audit right where we live, analyzing the massive amounts of carbon stored above and below our feet. When you compare these terrestrial bank balances, the numbers are pretty wild. Up in the atmosphere, we've got a storage balance of 750 gigatons of carbon. And if you think about all the lush vegetation, every vibrant forest, sprawling jungle, every single blade of grass on Earth, that holds 610 GDC. But here's the real shocker, the soils. The dirt right beneath our feet holds a massive 1,580 GDC. That means the soil is storing more than double the amount of carbon than all the plant life on the entire planet combined. It really highlights exactly why preserving our ground and practicing sustainable farming is absolutely crucial. Disturbing that soil, it basically means busting open the planet's largest land-based savings account. So now that we've seen the balances, let's look at the actual transactions happening here. Through the super elegant mechanics of photosynthesis, the Earth makes a huge deposit. Roughly 121.3 GTC is pulled directly from the sky and deposited right into the vegetation every single year. But, just like any active checking account, there are withdrawals too. Through plant respiration and natural soil decay, 60 GTC is withdrawn from vegetation, and another 60 GTC is withdrawn from the soil, flowing straight back up. That's about 120 GTC going out, nearly perfectly balancing the 121.3 GTC coming in. Honestly, this equilibrium is a masterclass in planetary accounting. It's just a beautifully balanced natural harmony. Section 2, the ocean's massive carbon storage. Let's move to the ocean and see how this builds to unlock the ultimate carbon vaults. 38,100 gigatons of carbon. Just take a second to let the sheer scale of that number sink in. While the soils hold a highly respectable 1,580 GTC and the atmosphere holds 750, the deep ocean? It holds a staggering 38,100 GTC. This massive underwater vault completely dwarfs all the land and atmospheric storage combined. For sure, it is the undeniable heavyweight champion of the Earth's carbon ledger, locking away unimaginable wealth in the deepest, darkest depths of the planet. And this dynamic relationship the ocean has with the sky is just brilliant. Just like the land, the ocean is constantly trading with the atmosphere. We've got 90 gigatons of carbon flowing up from the surface ocean into the atmosphere through a process called outgassing. And, right at the same time, an almost identical 92 gigatons flows right back down, dissolving directly into the water at the surface. It is a spectacular two-way physical and chemical exchange. This constant rhythmic harmony ensures the largest reservoir on Earth stays perfectly balanced with the air above it. Section 3, Human Impact and Fossil Fuels. Now, let's examine the disruption of Earth's natural ledger. Deep underground, nature has locked away 4,000 gigatons of carbon in the form of fossil fuels. Now, for millions of years, this specific account just sat there completely dormant, a locked vault untouched by time. But here's the thing. So, the crucial point is exactly what is happening to that vault today. We are now seeing a flux of 5.5 GNTC per year rising from our factories and cities. Through fossil fuel extraction and cement production, human industry is making a strictly one-way withdrawal. We're literally taking 5.5 gigatons out of deep, long-term storage every single year and pumping it straight up into the atmospheric checking account.
So what does this all mean? To really grasp why this matters, we have to conceptualize this by comparing the natural systems directly with human industry. The natural fluxes are massive. We're talking about those 90 to 120 gigaton transactions we just looked at. But they're inherently two-way streets, right? What goes up comes down. Now, human impact at 5.5 GTC might mathematically look kind of small in comparison. However, because it is a completely unbalanced one-way street, that 5.5 GTC has nowhere to go but up. It doesn't cycle back into the deep earth, it just continuously accumulates in the atmospheric account, fundamentally disrupting the equilibrium of the whole shebang. So as we wrap up our audit today, we've seen the totally mind-blowing scale of Earth's carbon cycle. We've marveled at the soil's vast wealth, the deep ocean's unimaginable vault, and the elegant, balanced transactions nature performs every single year just to maintain equilibrium. But we've also clearly seen the stark data on how a continuous one-way withdrawal is shifting that very balance. The numbers are right there on the ledger for us to see, plain as day. So the question I want to leave you with is this. Knowing how delicate and mathematically precise this planetary bank account truly is, can we protect this natural balance for the future? Thank you so much for joining me in this explainer, and keep questioning the world around you.